A very good evening to all of you. So, the title of my topic is Emerging Technology and Analytics for Enhancing Predictive Maintenance. Uh, I am working in Uran plant in instrumentation section in C2 C3 department. I am working in Uran plant for last 13 years. So, the idea of this topic is about what are the new trends and technologies that is evolving in the field of predictive maintenance. So this predictive maintenance, after the presentation you would be able to know about the new things which have come up, and we would be dealing with some of the new aspects of predictive maintenance, be it artificial intelligence, machine learning, digital twins, or in the sense AR, VR, and cloud computing, edge computing. So these are some of the things which we would be discussing. The idea here is to make you aware about the ongoing trends available in this industry. We would be also discussing about some of the key learnings, case studies, and how the industry have benefited out of it. So the idea is why there is a need for predictive maintenance. The maintenance journey starts from reactive maintenance to condition based maintenance to preventive maintenance, then predictive maintenance, and last one is your proactive maintenance. So every strategy has its own pros and cons associated with it. The moment you talk about reactive maintenance, it is simply a planning and execution. The moment something has gone bad or if an equipment is down, then we came into action. We do all the quotation from the vendor, then following up, then we may have certain key learnings associated with it. We may adopt those things. Afterwards, we also try to have the spares associated with it. We try to categorize the instruments based upon the requirements, such as safety critical, plant critical, process critical, or redundant systems. We try to figure out which one is the bad actor and try to work upon the thing. And in some certain cases there needs to be some sensors which needs to be put up. So that comes in the condition based monitoring. We used to take the thermal imaging or the spectrum analysis, and on the basis of it we interpret. Nowadays there are analyzers which can have AI prediction also associated with it. We can consider those also. Now the thing is predictive based maintenance. Predictive based maintenance means we have two or three kinds of data. The first one is the process data, second one is your machine data, and maybe your third one may be your lab data or something key learnings from your SAP modules also. So based upon which, if a use case history is also available, that can also be integrated. So based upon all these data collection is the key thing here. So for all the critical things, already there is something available in the machine which is there to have the story, or what you can say, something which is very much available. You do the analysis, capturing of the data is the primary aspect, after which there would be certainly related to the processing of the data, and before processing, cleaning of the data is required. So it would be having lots of noise, some of the data might be missing. So the what the modern AI and this machine learning does is, it does the cleaning of the data, it sanitizes the data and puts it into a very customized form so that it can be understood by a larger group. That data is being processed through your artificial intelligence and machine learning algorithms would be running in a particular system. That system would be doing a time series analysis or a frequency based analysis, and it will be also having its own knowledge based. It would be comparing with its own use cases, and the more the data you have, the more it will learn. So it will be trained on very large set of data, so that there are equally important learnings which are also associated with it. On that particular aspect, there would be certain key learnings that might be associated. See, suppose if there is any variable temperature, pressure, flow, and we want to predict, like if in case of a compressor is a black box, then we try to design that compressor using the mathematical equations or the physics based principles or the thermodynamics principles, and those principles will typically tell us about uh, a steady state model would be created. So that model would be trained on large set of data. That data may be the historical data. If it is available, then it is a good thing. Otherwise, from the moment we establish the particular system, then it comes into picture. That training of the data is very important. If it the more the trained data is available, the more the accurate the prediction would be. That has to be carried out on the basis of certain things, such as the outlier needs to be removed. If there is any faulty reading coming out of the sensor, that needs to be discarded. Also, if there are certain abnormal operation, that also needs to be discarded. There has to be certain standard deviation below, after which needs to be discarded. So it depends on certain categories for which there has to be a proper planning. When the AI and this machine learning algorithms runs in the background, these algorithms will give you a clear picture, and that picture would be on the basis, if suppose my machine is operating on a particular limit. So it will be having three sets basically. First one is your design limit, another one is your operating limit, and the third one is your alarm limit, fourth one is your tripping limit. So suppose if there is a deviation in the operation of a particular, say, bearing element, that and there is a certain amount of vibration associated with the bearing element, that vibration needs to be discarded or it has to be taken care. It depends upon your operating limit, like how it is it decreasing gradually, or is it increasing in a constant fashion or a particular fashion. And along with that, if certain other abnormalities are also observed, if suppose there is an increase in temperature also being observed, so something like that, which will give us a true picture that that an attention needs to be taken care, based on which an alerts and notification would be generated. It can also be integrated with the SAP module to have a better picture. This notification can in turn be clubbed with the final data source. final outcome like giving a PR or PO to the ERG group and then doing the processing. We can automate this whole process. So once that notification and alert is there, and we can also visualize this whole thing in a graphical format or in a dashboard format to figure out. It can be implemented to an enterprise wide to figure out like where do we stand, like if suppose say 50 on 50 equipments we are running the predictive maintenance. Based upon our experience, we can find out which one is the critical and which needs to be taken care. It can be segregated into risk matrix also, based on which we can tell how good our understanding is. It can be it will learn over the period of time. The advantage of this predictive maintenance is it will give us an very much improved reliability, and we can take a pre-planned decisions about our overhauling and the maintenance practice. It will definitely reduce our downtime. Some cost savings is also available with us. When we talk about the current state of our maintenance practices, so the traditional method is predictive maintenance, is preventive maintenance. Now it is predictive maintenance. So the traditional method involves the overhauling of the machine based upon the certain use cases like number of running hours, or based upon the turnaround schedule or the OEM recommendations. Now the thing is to get into this predictive thing, but the challenges are also very much in the sense that if we go with the preventive maintenance, then there are higher costs and unplanned downtimes, and safety concerns are also there. So yeah, there are chances that vendor may or may not entertain us in a sense that he can simply discard, saying that the equipment will run for few more hours, but there can always be a conflict which needs to be discussed, and sometimes there are unplanned downtimes which can be avoided, and even there are safety concerns also if we are running the equipment beyond a certain value. Now but if you see the certain use cases, then definitely there is a very big scope for the improvement and coming to the emerging predictive maintenance. Now let's talk about what are all the emerging technologies. So when we talk about the technologies which is associated with the industry 4.0, or what you can say a predictive maintenance, so what are the key enablers or which will form a foundation? It is artificial intelligence, which is very popular buzzword nowadays. Everybody is using chat GPT and this Claude and this Canva. IoT, Internet of Things, and if you put one more I before IoT, that is Industrial Internet of Things. So this is a really a surprising thing which can have a very different kind of impact, in the sense that your whole the data depends upon your physical process environment. The process environment comprises of pressure, temperature, flow, or vibration, or frequency. So these things can be captured with the help of your IIoT sensors. Nowadays sensors have come in such a way that they can capture data through wireless gateways, and that gateway can be centrally connected to a server or to a remote location on which the processing of the data can also takes place. So this is a very key aspect associated with the emerging technology, the invent of this IoT sensors. And when we talk about the big data, these IoT sensors are capable of capturing data in the terms of milliseconds and seconds, and even high frequency data is also available. So to handle these all bulk amount of data, there is a requirement of this big data. It is a kind of a machine engine which will be running in the background and performing all the calculations and cleaning of the data, and whatever like data mining, it would be taking place there. And once we go into this machine learning thing, that is basically based upon the used cases and also upon the history of certain past failures or past experience which will come into picture. Or otherwise, if the data sets are not available, then it will start learning from the design thing, so that there are new challenges which are there. That these kind of technology will definitely provide a huge boost to the machine learning. There are certain things associated. Machine learning and artificial intelligence, these terms are somewhat used interchangeably, and they are like core of the phenomena these days. Now when you integrate all these technologies in the process industry, or say in oil and gas environment, then it creates a huge value. But we need to be critical, like how much we need to do and how much is doable, and what is our limitations also, so that an informed decision can be taken place. Now let's talk about how is the analytics role in terms of predictive maintenance. So the data collection would be nothing through your sensors. So what sensors will do is it will physically convert your process data into some kind of an electrical signal, which would be understood by your smart IoT device, and that IoT device would be again connected to your gateway, and that gateway will be again connected further to your DCS system or your plant historian, and that historian would be having the capability to handle the multiple wide amount of data, huge amount of data, so that it can process it very very nicely. And again, in the background there are many algorithms which would be running to have the data compression factor also in place, so that it would be a good things to do. When we talk about, let's jump upon to the ABB predictive maintenance solution case study. So what ABB has done is it has identified one of its green power plant in the Spain, and have been trying to figure out like what are all the critical aspects associated with it. And they have applied their Genix is their platform, in which basically they were able to predict very fastly about the impending failure which has come up, and it has drastically improved their productivity as well as bring down the overall operational cost, and they can plan the things in a much better way. So by the 10% of the equipment failure, if it is able to achieve, then it is a great investment. Even if a one breakdown is being achieved, is being detected by the system, then it is a win-win situation for them. And ABB. So now let's talk about the predictive maintenance framework. So when this whole framework works through goes through 4 steps. First, the collection of the data, that is through your IoT sensors. Then that sensors will collect the data and it would be acquired through a data acquisition system, and that data acquisition system would be connected to your IIoT gateway, and the processing will takes place in the historian. That processing will takes good care about the quality of the data is also very important. Say if a particular sensor is not working, then it has to figure out that it needs to discard that particular sensor and do the processing. Then the analysis would be carried out. The analysis would be somewhat similar to which is being done through your analyzer, and it will also have the study related to the process part also. When we talk about a compressor may malfunction because of its gearbox failure, or may also about if there is something wrong about with the lube oil which is going through it. So that thing needs to be taken care automatically, and it comes with the experience and with the knowledge base which is inherent in the model. And also while developing the model, they OEM can takes care of this particular aspects. So it is a very challenging thing, and it is done on a step by step process. When we talk about this IoT and sensor technology, so this is something which is new, which has its own limitations also, but flexibility is also very much available. That there at present there are certain types of sensors which are zone 1 and zone 2 classified and ATEX certified, and they are available with the vibration, temperature and pressure and flow also, so that they can be they are able to connect to the process directly without interrupting the process, and giving us a fair idea about how the things are. And thus these sensors, since they are smart IoT enabled, they can be connected to any of the existing wireless gateway or any new gateway also, and which would be again connected to IoT network, and again it can be again further extended to the IT infrastructure also. When we talk about this data management in the predictive maintenance, so there are two kinds of things which is there. One is the cloud based solution, another one is the on premise solution. When we say the cloud based solution, then automatically there are certain things which again comes into the picture, whether to have it's our own public cloud or the private cloud. So ONGC at present is not I am not sure whether it is a cloud ready or not, but the need of the hour is to have our own cloud, so that we can deploy the resources, and we can sit back and relax to forego our cloud requirement, or and we can simply sit back and simply not worry about our data being lost, and figure out like how it will work effectively. But again, if there are on premise solution, then there is a networking infrastructure which comes into picture, and there are failures also which is there. And the cloud based can have a huge advantage as comparison to the on premise solution. The reliability also increases, and accordingly accuracy also gets into picture, which can be taken care. When we talk about the further machine learning algorithms, so there are like 3-4 kinds of learning in the machine learning: supervised learning, unsupervised learning, reinforcement learning. So what does a supervised learning is? Say for example, there are certain things which needs to be taken care. I'm not reinforcement learning is make the model how does a child start to walk. Let's take an example. So first what child will do is child will start to crawl, then child will try to stand up on its own by taking support. Afterwards, what child will do is it will move one step forward, one step backward, baby steps basically, and then afterwards it goes into the walking mode. So this whole pattern is being conveyed through the reinforcement learning. So once we have the data set available with us and all the things which is there, then there are certain capabilities which can be very well thought of. It can help us to optimize our maintenance schedule, and we can plan well ahead in time to decide our future course of activities. Now comes the real-time monitoring and analytics. It can be remote monitoring also, it can be real-time monitoring also. It depends, like we can have a dashboard, an enterprise-wise dashboard also, or the dashboard based upon the criticality or based upon the power uses or whatsoever our requirement is. It can be customized, and like what are all the alerts which have generated over the period of time. We can also have a study about like what is the failure, and like how good it is to have this failure, and when did this failure occur, and if suppose a particular failure has occurred to a particular thing, then how it can be avoided next time, so that it will behave well in advance. The model will model will learn in an environment which will be flexible enough to predict. It will give us an early warning also, early warning of the failure of any mechanical equipment, as well as the failure through the from the process point of view also. So different industries are having their different approaches to look into this, and it can give us immediate output, and we can move on to the proactive maintenance also. When we talk about our specific challenges related to oil and gas, so the challenges here is that we work up in the very harsh environment, and machinery is sometimes too much complex. So that is one key picture which is a bottleneck, or maybe we need to take the help of OEM in also. So depending upon our case requirement and case to case basis, it can be a customized predictive models, and also there are like industry specific tools uh, which will give us an insight of how to do this particular thing. When we talk about the ONGC's digital transformation journey, so it is really incredible the way, if we want to see to our vision of 2040, then to have this to achieve our goal of 9x of our market cap, 3x of our revenue, 4x of our sales, then digital enablement, we cannot think of it without our digital enablement. It is the need of the hour, and accordingly we have to brought many things into the picture, so that how we are lagging and how much more we can do on day-to-day basis. And we can also always boast of about like how is the certain parameters which are there, and certain parameters which needs to be taken care. So we had our engagement with the Accenture as a digital consultant, which has tell us like these are the particular things which needs to be taken care,